So what I'm going to do now is take a look at 4x AS numbers. Okay, so we're going to look at 4-byte AS numbers. These again are very important. As I was saying on Monday when I did the BGP presentation, there are only about 3,000 16-bit AS numbers left. So they will run out probably by the end of this year, early next year. And then if you need, or your customer needs an AS number, your customer will get a 32-bit AS number. And if you are the ISP, you need to know what to do with it. If you don't know what to do with it, you will lose your customer. So you need to be very aware about these 32-bit AS numbers. So the standards, RFC 4893 describes 32-bit AS numbers. How they're represented is RFC 5396. There's a new extended community for them. AS23456, as I said on Monday, is special. AS23456 is used to represent 32-bit AS numbers on routers that don't know how to configure 32-bit AS numbers. And so 23456 is special. So if you look at an older router today and do show IPBGP, you will see lots of 23456s in the network. Okay? So 23456. Now, when I talk about 16-bit ASNs, this refers to the range 0 to 65535. So that's the 16-bit ASNs, 0 to 65535. 32-bit ASNs refers to the range from 65536 above. And when we talk about the 32-bit pool, we mean everything. This is just the terminology that's used. So 16-bit up to 65535, 32-bit 65536 and above, and the 32-bit pool is everything. So how to get one? Well, 32-bit ASNs were available from the 1st of January 2007. You could get them if you want. From 2009, that's what you got. And from 2010, the registries did not distinguish. So now, if you go to APNIC and ask for an AS number, chances are you will get a 32-bit AS number. The hostmaster team does not distinguish, they just pick a number. In fact, the number you get will be from a 32-bit ASN. It's unlikely to be the old 16-bit, because the hostmaster team is keeping the 16-bit ASNs for people who cannot use 32-bit ASNs at all. So that's the policy. So nowadays, you just get one from the registry. You don't have to ask anything special. Representation, there were 3 formats proposed. AS plain, AS dot, AS dot plus, just so you're aware. In reality, operators prefer the traditional format. So as we write them down now, just like a standard integer. That's how operators prefer ASNs now. Some people want to use the dot notation, so they write it x dot y. So the x is the first 16 bits, the y is the second 16 bits. Right, so for things like AS dot for 65536 upwards, for example, 2.4 rather than 131076. They want to write it that way. There's a big problem with the dots. Some people wanted to use AS dot plus, in other words, convert the entire pool. So even we write the old AS numbers as 0 dot something. So I think it's only Quagga that uses AS dot plus, where they write all the ASNs with the dot notation. The problem with the dot is that regular expressions have to be completely rewritten. That's the problem. For example, this thing here matches any AS. Right? So this is 0 to 9, any number 0 to 9, at least one of. So this matches any one autonomous system. So if we're using 16-bit ASNs, or we're using 32-bit ASNs with the AS plain format, this is fine. And that's what ISPs have been using for many, many years to match ASNs, regular expression matching. If we use the dot for the AS instead, use AS dot format, well, it changes. We need this. So this matches any AS, but we need to be able to match an AS with a dot in it as well. So this says any number, dot any number. So this simple expression becomes complicated like that. Do you as an ISP want to go and change all your regular expressions to look like this? Probably not. AS dot plus at least is easier, but we still have to put the dot in. The dot is a special character in regular expressions. So it's a bit silly to choose dot as a separator for an AS number when it's already used in regular expression matching. I mean, it's silly to even think of this as an option. But, you know, the dot was chosen, some people wanted it, they thought it was a good idea, but very naive. So what you find is most ISPs will use this. And so that's why you look at all the routers, the default format is the plain format. So the changes, 32-bit ASNs are compatible with 16-bit. So there's no flag date. Right? It's not like V4 and V6 not compatible with each other. 32-bit and 16 are compatible. You don't need to throw out any of your old routers, because your old routers quite happily are using 32-bit AS numbers even though they don't know about it. You don't need to upgrade your AS number. If you're using a 16-bit AS number now, you don't need to replace it. It's just if you don't use BGP now, and you need an AS number for BGP, you will get a 32-bit AS number from the registry. That's the only thing to be aware of. You do need to be aware that your customers will come with a 32-bit ASN, and you need to be aware that you're going to see lots of AS23456 on the network. If you get a 32-bit ASN, your routers will need to support it if you want to use it. If your routers don't support 32-bit ASNs, you can't use them. There's nothing you can do. Also, if you have a proper BGP implementation, 32-bit ASNs will be transported silently across the network. There's a feature in BGP. If a BGP speaker receives an unknown attribute, it passes it on. That's what the BGP rules say. If you receive an unknown attribute, pass it onwards. So a 32-bit ASN creates a new attribute, and this new attribute gets passed along. That's why your 16-bit ASN routers don't care. They see the 32-bit ASN as an unknown attribute and just pass it on through the network. So how does it all work? Well, if the local router and remote router support 32-bit ASNs, you just carry on as normal, no problem. Local router and remote router do not support 32-bit ASNs, then you can only use 16 bits. However, if a local router only supports 16-bit, might be your router, and your customer comes along with 32-bit, then we go into what's called compatibility mode. And the way compatibility mode works is like this. The remote router asks your one, do you support 32-bit AS numbers? Your one goes, no idea what you're talking about. Right? So when the local one says no, the remote router says, oh, okay, they don't know anything about 32-bit AS numbers. I will pretend I'm an AS23456. So the local router configures their peer to be with 23456. Right, so the local router, you do router BGP, neighbor 23456. The remote router, router BGP, 32-bit AS number, neighbor 16-bit. So the operator of the local router has to configure BGP peering with AS23456. And that's this special compatibility mode. So here's the configuration. Local router only supports 16-bit ASN, so here we go. Router BGP 64510, neighbor, remote 23456. Remote AS23456. eBGP with AS131076. And then we have our filters. The router in the 32-bit ASN, router BGP 131076, neighbor remote 64510. This is normal configuration. So you see how you configure the compatibility mode? So you get a customer coming along with a 32-bit AS number. You can't put the 32-bit AS number in there. What you do is you put 23456 instead. But put in the description line, I twisted out actually, put in the description saying eBGP with AS131076. Ah, let me fix this. Okay, fixed it. Alright, so. But it's good idea to put the description in, because then you know who you're peering with. Okay? So you understand how this works? So now if you get a customer with a 32-bit ASN, you know how to do BGP with them. Of course, if you're using a router with a modern software, so for example in the workshop here we're using 15.1, that does know about 32-bit AS numbers, so there's no problem. But if you're using older Cisco software like 12.4, 12.3, it doesn't know about 32-bit AS numbers, so you've got to use this instead. But this all works fine. There are many, many ISPs using this setup. Right, so the BGP peering is initiated, session established using 23456. 32-bit ASN is included in a new BGP attribute called AS4 path. So we have the AS path with 16-bit ASNs, and we have AS4 path with the 32-bit ASNs. So the result is the 16-bit world sees 16-bit ASNs in 23456, and the 32-bit ASN world sees everything as normal. So we're back to this picture I showed you on Monday. Right, so we have AS80,000 originated prefix going to 70,000. AS123 peers with 23456 because they don't know how to peer with 70,000. So here they peer with 23456. So what happens is AS123, so AS70,000 has the 32-bit ASNs. It knows it's talking to a router that doesn't know about 32-bit ASNs, so it sends 23456 instead. So in AS123 and on AS321 we see 180.10.16 heard from 123, 23456 replacing the 32-bit AS numbers. Whereas we go to a router that does know about 32-bit ASNs, we see the 32-bit ASNs normally in the path. Okay? Because the router that does know about 32-bit ASNs looks for the 4-byte AS path, and wherever it sees 23456 coming from 123, it just replaces them back in again. So it's a very, very clever compatibility mode. But this is how it all just works. The internet has been using 32-bit ASN since about 2006. It's been using them that long, and you don't even be aware of it. Two new attributes: the AS4 path carries 32-bit AS path information. AS4 aggregator carries the aggregator, or 32-bit ASN aggregator info. Well-behaved BGP implementation simply pass these along. That's what the BGP spec says. If you don't know what the attribute is, pass it onwards. And of course, we've got AS23456 that transition AS. So what do they look like? Well, I sit on this router here. This router is running in AS plain format. This is show IP BGP of a prefix. here's the AS path. So this is 131072, 16-bit AS, and then 196613. So that's the AS plain format. If I switch the router into using dot format, it becomes 2.0 and 3.5. Okay. So that's the difference between the AS plain and AS dot. If we sit in the 16-bit world, then same prefix, but this time we don't know what the ASN information is, so it's 23456. And so we get 23456 standing in for 2.4 and 2.0 and 3.5. If you don't support 32-bit ASNs on your network, they're all going to be represented as 23456, which means you can't distinguish between customers using the ASNs. Could be problematic for your policy, but of course that's what BGP communities help with. You can put the customers into different communities, then you don't need to match per AS number. It means you're not able to distinguish the prefixes origin AS either. So how do you tell whether origin is real or fake? I don't know. There is no answer, because you don't get any information like this. So this is probably a good reason for you to make sure you upgrade the software on your routers to get 32-bit ASN support in there. Also with NetFlow, if any of you are using NetFlow, prefixes from 32-bit ASNs will all be summarized under 23456, unless you're using NetFlow version 9. But then you need a router that supports 32-bit ASNs. Okay, so it's probably another reason to upgrade the software. Unintended filtering by peers and upstreams. Even if the Internet Routing Registry supports 32-bit ASNs, some ISPs' tools still have not been extended to support 32-bit AS numbers. Okay. And of course, the some ISPs don't even realize that 23456 is the transition AS. So they filter that out. So that's not good either. So implementations, I mean, I haven't updated this for a year now, but not much has changed. These are all the different software versions. So Cisco iOS XR, XE, the different iOS releases that support 32-bit AS numbers. If you're using the Nexus switch, it supports it from quite early on. If you're using Quagga, 099.10, OpenBGPD 4.2 onwards. Juniper's had it for a long, long time, 4.1 and 9.1. Redback has had it even longer. Force10 has it, and many other vendors have them as well. In fact, the complete list is here. Right, so this wiki page has the complete list of 4-byte AS number support. Okay, looking at the actual Cisco routers, so if you've got a Cisco CRS 3.4 XR, GSR 3.4 XR, otherwise these iOS releases, ASR 1000, XE 2.3 onwards, the Nexus switches 4.0 onwards, Catalyst 6500, you need SXI 1, 7600, you need SRE 1. I mean, honestly, if you're using older software than this, you shouldn't be. There are too many bugs, too many security problems with them. Get onto something more modern. 7200 series, well, the various different types of software here. Probably, you need to be on SRE1 or on the 15.0 software really to get the 4-byte ASN support. 7301, it's the same as 7200, same thing. Using 3900s and all the 900 series routers, 15.0 onwards, 2800s, 15.0, 3745, that's all you've got. 5300s, AS5300, 5400, this is all you've got. Routers which will never support 4-byte AS numbers, these are the very, very old ones. 2500, 2600, 3600, 5300, 7304. These are ancient routers. I mean, I don't know, these should really be in a museum now. They're very, very old. 2500 is from what? when was the 2500 appeared? About 1995, 94, sometime. Yeah, it was about 1994. And there's still people using them. So it's probably the longest, oldest router ever on the internet. But these are all ancient bits of hardware. I've also got some slides here about how to deploy 32-bit ASNs in the network. I'm not going to go through them, but you know, if you have a situation where you don't have BGP now, and you've got an AS number from APNIC, and you need to deploy BGP, but it's a 32-bit AS number, the next set of slides are useful advice on what to do. Okay, so I'm not going to go through them. So they're there for information, or if you have customers who need help, you know, you might have your normal AS number, your customer's got one from APNIC, they don't know how to deploy it on the network, so the slides here will show you what to do. Okay? Any questions about that? No? Okay, I think now is a good time to have coffee, given I've heard coffee cups for the last 10 minutes. So let's have tea, coffee, come back at 11, and I'll explain the lab, and we'll do the BGP Route Reflector lab. Okay?